How are hazards identified in aircraft systems? Before performing detailed analysis, engineers must first understand what can go wrong. This is the purpose of functional hazard assessment. Functional hazard assessment is a key method defined in ARP 4761A. It focuses on system functions and identifies potential hazards based on their failure. There is also an important distinction. Functional hazard assessment can be performed at aircraft level and at system level. In this video, we focus on system-level functional hazard assessment and how it is used in aerospace safety assessment. Why is functional hazard assessment so important in aerospace? Aircraft systems must operate safely under all conditions. Even a single failure can lead to hazardous situations. In some cases, the consequences can be severe or even catastrophic. This is why hazards must be identified early, before detailed design, before implementation. Functional hazard assessment provides this early understanding. It links system functions to potential hazards, and this forms the basis for safety requirements. It also plays a key role in certification, because hazards must be clearly identified and justified. So, what is functional hazard assessment? Functional hazard assessment is a key method in aerospace safety engineering. It focuses on system functions and analyzes what happens if those functions fail. The goal is to identify hazards based on functional behavior. Instead of looking at components, it looks at the system from a functional perspective. It also evaluates the effects of failures on the overall system. Functional hazard assessment is typically performed early in system development, and it provides the foundation for further safety analysis. There is an important distinction in functional hazard assessment. FHA can be performed at different levels. At aircraft level, the focus is on overall aircraft functions. This includes high-level hazards and their impact on operation. At system level, the analysis becomes more detailed. It focuses on individual systems and their specific functions. This leads to a deeper understanding of potential hazards. System-level FHA is especially important because it directly influences system design and safety requirements. So how is functional hazard assessment performed? The process starts with identifying system functions. Each function is analyzed to understand its role. Next, potential failures are identified. This means asking, what happens if the function does not behave as intended? Then, the effects of these failures are assessed. This includes understanding how the system and the aircraft are impacted. Finally, the severity is classified. This step determines how critical the hazard is. The results of this process form the basis for safety requirements. What are the outputs of functional hazard assessment? The first result is a list of identified hazards. These hazards are linked to specific system functions. Next, the severity of each hazard is classified. This defines how critical each situation is. Another important output is safety requirements. These are derived from the identified hazards. FHA also provides input for further safety analyses, such as fault tree analysis or failure mode analysis. Overall, the results of FHA form a key foundation for system-level safety. Where does functional hazard assessment fit into ARP 4761A? FHA is one of the first steps in the safety assessment process. It is performed early, before detailed analysis begins. The goal is to identify hazards based on system functions. The results of FHA are then used as input for further methods. These include preliminary safety assessment and detailed analyses like fault tree analysis or failure mode analysis. Finally, all results are combined in the system safety assessment. So, FHA forms the foundation for the entire safety process. What challenges arise in practice? One of the main challenges is defining system functions correctly. If functions are incomplete, hazards may be missed. Another challenge is identifying all relevant hazards. It is easy to overlook less obvious scenarios. There is also a risk of being too generic. Hazards must be described clearly and precisely. Consistency in severity classification is another important aspect. And finally, FHA results must align with system design. Otherwise, they do not provide real value. There are several common mistakes in functional hazard assessment. One of the most frequent is defining functions too vaguely. If functions are not clear, hazards cannot be identified properly. Another mistake is missing important hazards. This often happens when analysis is not thorough enough. It is also common to mix functions and failures. These must be clearly separated. Consistency in severity classification is another critical point. And finally, FHA should not be treated as a one-time activity. It must be refined as the system evolves. Let's summarize the key points. Functional hazard assessment identifies hazards based on system functions. It is performed early, in aerospace safety assessment. The results are used to classify severity and define safety requirements. FHA also provides the foundation for further safety analyses, and ultimately, it is essential for ensuring safe system design. If you want to go beyond this introduction to functional hazard assessment, we offer a wide range of online training programs on our website. In aerospace, we cover system development, safety assessment based on ARP 4761A, and software standards like DO178C. In automotive, we provide training on functional safety, SOTIF, cybersecurity, and development processes such as Aerospace. We also cover medical devices, where safety-critical development and regulatory requirements play a key role. You can find the link in the video description and in the pinned comment below. If you found this video helpful, feel free to like the video, leave a comment, and subscribe to the channel. We regularly publish content on safety-critical systems, engineering standards, and real-world applications. And if you're interested in this topic, you might also want to check out our videos on ARP 4761A, DO178C, and HERA.